Hi everyone, this is Fahad Mirza and welcome to my channel. And I know that you have been waiting for this video where we are going to locally install this newly released Alibaba's Qwen 2.5 coder 32 billion instruct model. This has really topped up most of the benchmarks and charts already. We already have covered the other variants in this family which were 7 billion, which is by far is the best model from Alibaba when it comes to coding at the moment. We very rigorously tried it out in our previous video, as you can see on the channel, but for this video we are going to check it out, this new model which looks really cool to me. Before I get to the installation, let's have a quick look at what exactly this model is. So this is the latest series of code-specific Qwen LLMs. This model we already have covered in 6 sizes from zero point 0.5 to 7 billion, and now today we are going to check out the 32 billion. As usual, this model excels when it comes to code generation, code reasoning, and code fixing. And we won't just believe on these words, we are going to test it out on various coding stuff. One of the things which really stands out that it has already beaten GPT-4o on various benchmarks, and those benchmarks are quite quality oriented, and the data is shared on their Hugging Face card, which you can check it out. Also, they have introduced another concept of code agents, so it means that you can build agentic software quite easily which are geared towards coding by using this Qwen 2.5 coder model. Another cool thing is that it supports up to 128k tokens, so it means that you can stuff up a lot of your own private code into its context at one point in time, which is quite cool. So again, it's a usual causal language model. They have done both base training and also instruction tuning with it. It supports rope, Swiglu, RMS norm, and also the QKV bias, which if you don't know what these things are, we already have checked them out on the channel. The actual parameter number for this model is 32.5, and the non-embedding ones are just 31 billion models. There are 64 layers, and it also supports grouped query attention. So that is a quick overview of this model. Let's try to get it installed and test it out. Before I do that, let me give a huge shout out to Massed Compute, who are sponsoring the VM and GPU for this video, which I will also show you shortly. If you're looking to rent a GPU on good prices and really affordable prices, I will drop the link to their website in video's description. I'm also going to give you a coupon code of 50% discount on range of GPUs, so do check them out. I am using this Ubuntu 22.04, and I have this GPU card which is NVIDIA H100 with 80 GB of VRAM. It's a big huge model, 32 billion parameter size, so you would at least need that. Hopefully it will be okay for this video, so let's check it out. As usual, I'm going to create a virtual environment with Conda. It is not mandatory but always a good idea to do so. And that is almost done. Next, let me allow to install all of these prerequisites, which are torch, transformers, and other tidbits. This is going to take a minute. And all the prerequisites are done. Let me launch my Jupyter notebook after creating it in the Conda so that we could download and play with this model in the browser environment. And the Jupyter notebook is launched. Next, let's download the model, this 32 billion instruct one, and then also the tokenizer. And the model is being downloaded. There are 14 shards of it, so let's wait for it to finish downloading. This is going to take a bit of a time, as you can see. Model is still being downloaded. While that happens, let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language for retrieving data from web pages. It works on any page, whether it is public or private, any site, any URL, even behind authentication. It uses natural languages to pinpoint the information you are looking for. It is quite resilient to page structure changing, a super selector, and it can be reused across multiple similar pages. And I will drop the link to their website in video's description. Okay, so almost there. So I think 2.5 shards are remaining. And now last shard is being downloaded. And the model has been downloaded with the tokenizer and it is also loaded onto our GPU. Let me run the first inference. So what I'm going to do here, I'm going to test it out on various coding related questions with diverse languages, and we will be trying to give it some really complex task, because I'm hoping that this will be much better than 7 billion, so it won't be simple questions, rather diverse ones. So for instance, if you look at this one, so I'm asking it that write a Python program that reads a text file containing a list of URLs and check each URL for its HTTP response status code, and then classify them and save the result into a CSV file. Then I'm converting this into a chat template using tokenizer to convert that text prompt into tokens, which are understandable by the model. Model is generating the output with the help of these hyperparameters. You can increase it if you like. Maybe I'll just increase it a bit. And then we are generating the output from the model, converting or decoding it back with tokenizer and printing it out. So let me run it. And there you go. It has given us this code, which you can see there is a preamble of this code. Then it is importing these libraries. And then this is a classification of HTTP status codes differently. There is a function for checking URLs. And look at this, how good this looks. Really, really, I would say a rich code with proper instructions and everything. Proper indentation is there. And then there are instructions as we need to install this and then prepare the input file, run the program, check the output. How good that is. Now while that happens, let's also check the GPU consumption. So if I run this, so you see it is consuming around over 63 GB of VRAM for this model. So I think you would need 80 GB of VRAM at least in order to get this model running. Now if I clear the screen and let's try to run this code in our Python code. I haven't run it yet, so I'm not sure how it would go. So if it doesn't run, don't shoot me, but let's try it out. I am going to follow the same instructions which it has given us here. So first thing, it is saying that install this pip install requests. So I'm just going to maybe copy it from here and then go back to my Conda environment. I'm using the same one. So it is already there. That is cool. Then it is saying that prepare the input file with urls.txt. Maybe what I'm going to do, I'm just going to go here and then I'll just create a directory my code, cd my code, and I'll just open it in the VS Code editor. So as per the instructions, I have just created this urls.txt. I have given it this HTTPS URL, google.com, and then some invalid URL. We just want to check the HTTP status code. And then I have just created a Python file where I have pasted the whole code from there. And now let's try to run it. And as I was saying, I haven't edited anything. I will be running it in front of you. So let's see if it works or not. Let me run it. Okay, so it should, I think it should save something in results.csv file as per this. Let's see what it has created or not. It has, and it should also be visible in our VS Code. There you go. So this is the result.csv. There you go. Fahad Mirza is correct. Google.com invalid because I think it needs. There you go. So perhaps you meant this. This is the model talking to you. How good is that? And then Uba Puga, this says invalid URL. So you see the code which it has generated, I have run it real time in front of you. Works like a charm. Beautiful model. Okay, so that is done. Now let's go back and try out maybe a JavaScript one. In this JavaScript code, I'm asking it to create a Node.js command line application that takes a directory path as an argument, recursively check all files within the directory for JavaScript files, and outputs a summary report listing each file and the number of function it contains. So let's see what it does here. Let's have a quick look at our GPU consumption. Should be similar, but let's have a look. Yep, it's a similar one. So over close to 64 GB of VRAM. Okay, so it is still running. Let's wait. And there you go. So look at the code. So again, it is going step by step, and it has just given me until here. I think I would just need, it is quite good. Yep, doesn't look bad to me. But it's not giving me more output. No, sorry, there it is. So I just didn't see uh, the scroller, but you see step by step, amazing stuff. So the way it is creating it, you can simply copy paste and run it, and it will run. This is what I really love about this. And look at the code, really looks good to me. Amazing stuff. And it is telling you how to run this, and then there is some explanation of the code. Beautiful stuff, really, really impressive, very impressive. Okay, let's try out another one with the C++. Let me put it in a proper format. And it has created the C program that solves the n queens problem using the backtracking. It's a quite a famous problem in C++. So look at this. It has given us the synopsis of the code, and then it is using this C++ with all the namespaces. Really good stuff. And then designing some function, and look at the way the code has been written. This is very, very high quality, very high quality. And then it is telling us about how the program works. Amazing stuff. I think benchmarks are not wrong for this model, really. And now I have asked it to write a Go program that acts as a simple HTTP server. The server should handle two routes: greet, which returns hello world, and date time, which returns a current server date. And it has written the Go program. So if I go down, there you go. It's a simple Go program, looks awesome. Yeah, proper routing is there, handlers are there, main function is there, and then it is describing us, explaining the code, and also telling us how to run it. And there is a sample one. How good is that? How good is that? Okay, now let me do the code translation. So there are two things which I am testing here. One is I'm testing it that convert the JavaScript function into Delphi. So one is the code conversion or code translation, and second is that if it is aware of this a bit older language, Delphi. There you go. Yep, that's a Delphi code. Looks really good, really amazing. And now I am testing it for code repair. So I have asked it to identify and repair the bug in this Ruby method. So if I scroll down, there you go. So this is a check anagram, correct? It has also understood what this function is doing, and then it has fixed it. There you go. So there is a fixed version that looks really good. It is also telling you that this version of the method first checks if both this and this are instance of string. Very nice. Very good stuff. Okay, let's try out a final one with SQL optimization. So if you are a database administrator or SQL developer, you know that how important and cumbersome this is. This SQL is correct, but it is not optimized. I have asked this question from lot of models, and most of models really struggle to answer it. So let's see what this one does. I'm hoping that it is going to optimize this SQL code. So let's see. And it has optimized the query. So let's see what it has done here. Let's go down. So it is saying that we can make several improvements to enhance its efficiency, performance, and readability. Very nice. Explicit join, yes. A filter for mode, exactly. This is what I was hoping for. And then the usual stuff around indexing. So if you look at the optimized query, it is using with block, rank order, amazing. Filtration is being done, and then there are some joins here, which is totally NC standard. So this is amazing. And then it is telling us about common table expression, CTE, very nice. And then row num, inner join, filtering, and all that stuff. Beautiful. So look, if you ask me what is the best coding model at the moment, especially in the open source ones, I would say Qwen2.5 Coder 32B Instruct at this point in time today. I don't know what would happen tomorrow because things are changing every day. Yesterday we covered another model which I showed you earlier. And by the way, I already have covered a lot of Qwen2.5 coder models. So yesterday, if I just quickly go to my channel and show you the open coder. So I just did it yesterday. It was really good model, just an 8 billion. but I believe this model in 32 billion is way better. So if you're looking for an alternate of your closed source API based model for a free model, there you have it. So really hats off to Alibaba for producing this full box. I hope that you enjoyed it. If you did, please consider subscribing to the channel. If you're already subscribed, do me a favor and share it among your network as it helps a lot. Thank you for watching.